Let's talk about the simple harmonic oscillators and the expression for their time periods. For simple harmonic oscillations, one thing should be borne in mind, that there is always a restoring force that is opposite to the displacement. Whether we talk of angular SHM or whether we talk of linear SHM. For example, we take a linear simple harmonic oscillator whose mean position is C, extreme position 1 is O, and another extreme position is D. Let at point P its displacement from the mean position be equal to Y. So at P there is a restoring force F that is directed opposite to that displacement, which tries to bring it towards its mean position. So that restoring force is opposite to displacement. We can say that if the restoring force is given by F, that will be equal to minus times Ky. Why? K is the spring factor. What is the spring factor in linear SHM or in linear simple harmonic oscillators? We can show that this spring factor is force per unit displacement, that is F divided by Y. And from the equations of velocity and acceleration of simple harmonic motion, we know that acceleration is equal to minus omega square y. As the force is opposite to the displacement, so acceleration is opposite to the displacement in case of restoring force. So we can say that acceleration is equal to minus omega square y. Now from Newton's second law, force is equal to mass into acceleration. So we can say that force that is equal to minus m omega square y. As it is the same restoring force, so we can equate this equation and this equation. From equating this equation and this equation, we have that minus ky is equal to minus m omega square into y. Minus and minus cancels out, y and y cancels out. So we can show that omega square is equal to k divided by m. Now we know that omega is equal to 2 pi divided by t. So 2 pi divided by t is equal to root of k divided by m. So time period will be equal to 2 pi root of m divided by k, where m is the inertia factor and k is the spring factor. We can also write it as time period is equal to 2 pi root of inertia factor by spring factor. So in case of linear oscillators, linear simple harmonic oscillators, we have to look what is the spring factor and what is the inertia factor. In case of angular simple harmonic oscillators, we have to look what is the inertia factor and what is the spring factor. In linear SHMs, the spring factor is force per unit displacement and the inertia factor is the mass of the body. When we talk of a mass attached to when we displace this mass, a restoring force is developed in this spring by which this mass oscillates simple harmonically in linear direction in one line. That means it is linear simple harmonic oscillator. In this case, time period will be equal to 2 pi root of m by k, that is inertia factor by spring factor. Here the k will be equal to force per unit displacement and the inertia factor will be equal to the mass of the body attached to that spring. In angular SHMs, that means when we are having a simple pendulum that oscillates between two extreme positions going through a mean position, here the inertia factor is equal to the moment of inertia and the spring factor is equal to the restoring torque per unit angular displacement. Thank you.